Hello everybody, welcome to lab today. Today it's rocks, and I'm going to talk to you a little bit about the most common types of rocks that we see out there, some of the uses of them. We're going to look at how we identify one rock from another and classify them based on their texture and composition. And we're going to see some cool stuff. I'm going to show you some beautiful pieces of marble and obsidian. I'm even going to show you a nice piece of schist and some nice rocks. So stick around, here goes rocks.
We will rock!
All right, let's begin part one, identifying common rocks. In this section, I've given you some common rocks that I put in random order: basalt, granite, limestone, sandstone, shale, and slate. And these are very common rocks that we see out there in the real world, and they're very significant to building stones, decorative stones, and things of the like. I'm going to take you through how to classify them, and geologists like to classify rocks based on texture and composition. And I went through and gave a good description of that at the beginning of this lab on the first page. And on the second page, I gave you a table of all of these common rocks and some of the things to look for. We're going to learn how to identify the texture, which is really the grain size and the grain arrangement, and the composition of rocks by looking at each one of these samples. So let's get started with sample number one. Sample number one is going to help us learn how to identify the grain size. If you look at sample one, you don't really see any particular differences in the grains. This is an example of a fine-grained rock. So in the grain size column, we're going to write fine. And the grain arrangement of this is a little bit difficult to tell. Grain arrangement is how the grains are put together. Either they can be cemented together, compacted together, they can be chemically interlocked together, and have some special textures as well. This particular rock, if you can see, it has kind of a pasty look to it, and it's got layers. This is an example of a compacted rock, a rock that was once mud, and the mud was pushed out and compacted into thin layers of clay and silt. And so this one here is a compacted rock. So I'm going to write compacted for the grain arrangement. The color, of course, is dark gray. And I'm going to go ahead and just write the color here to start with. We'll fill in the rest of the composition in a little bit. I do know that this is a sedimentary rock, and to get the rock origin, I really have to go to my data to my rock tables. When I go to the rock tables on the back of the first page here, I'm going to focus on the sedimentary rock classification, and I'm going to do that because I've given you the rock type in the table on row number one here, and it says that it's a sedimentary rock. So when I come to my sedimentary rock classification table, I'm going to go down and look for my fine grained here. And I'm going to come over, the grains are too small to see, and that's indeed what we found. Compacted breaks into chips. Interesting. Clay minerals, gray or black. This kind of looks like what we're dealing with here. Sedimentary rock type would be kind of the rock origin. That's clastic. And I think this rock is shale. So I'm going to go ahead and come to my lab here. For composition, I'm going to finish it and write clay minerals. My rock origin was clastic, and the rock name shale. And so that's how you're going to do the rest of these. All right. Don't worry though, I'm going to take you through the rest, or at least the first set here. Rock number two. The rock number two, when we look at the grain size, it is also fine. These are fine grains. It looks a lot similar to rock number one. There's these little compacted layers, but the difference of this one is that it is very solid. It's not the pasty sort of muddy, dirty looking thing that we had before. These grains look chemically interlocked. In fact, they look so chemically interlocked that we're going to call these grains interlocking, and we're also going to call them foliated. So we're going to go ahead and write this fine here, and I'm going to write interlock for the texture of grain arrangement, interlocking. And this is a black rock. And the rock type in my table says that it's metamorphic. So I'm going to go look at the metamorphic table here, and that one is here. And for my metamorphic rock table, I'm going to note that for fine grain, there's 4 choices. So this rock, right away, I can come over here and look. It's either quartzite, marble, slate, or phyllite. And non-foliated, grainy like sandpaper? No. Non-foliated, smooth or sugary? No. Foliated, flat sheets, smooth? Yes. Thin sheets? Yes, but silky sheen? No. So I'm going to follow this path. So it says here that this is foliated. So a foliated texture is a layered texture. So I'm going to write foliated in here for the grain arrangement. And further, it says that the composition of this then would be clay minerals. It's black or dark gray, and that does line up with what I've got here. So I'm going to write in clay minerals. And does this look familiar? The last rock was also clay minerals, and that one was shale. And note that the parent rock or the origin for this rock is also shale. So I'm going to go ahead and put shale right here. And the rock name then I'm going to write in slate. Okay, so the first one was shale, the second one here is slate. This is what blackboards are made of, slate. And sometimes floor tiles, maybe even shingles. Rock number 3. Rock number 3 is feels like sandpaper right off the bat. It's got a sugary look to it. In fact, the last 2 were fine grain. This one is a great example of medium grain, something that looks like you've shaken salt on it or sugar, and it's been cemented together. So this is indeed medium grain. So I'm going to write medium for my grain size. And my grain arrangement, it looks cemented. Now, how do I tell the difference? Chemically interlocked rocks have grains that are really kind of put together so that they feel almost smooth. You can tell that they're chemically interlocked together. These almost feel like I can scratch them off. This is a cemented version. Note that the color here is red, so I'm going to write pink or red for the color. And then I'm going to go to my sedimentary rock table, given by the rock type there. So I go to my sedimentary rock table, and we have medium grain. There's really only one medium grained rock, like sugar, sandpaper feel. It's cemented, made primarily of quartz. And it says here that, so I'm going to write quartz here for the composition. It also says that the cement's iron equals red. So I'm guessing I've got a red cement in here. So I'm also going to write iron for my composition here. So quartz and iron. Sedimentary rock. And then, of course, the origin then is clastic. And clastic sedimentary rocks are rocks that are basically cemented sediment together. The pieces of sand grains would then go to the ground. Water would come through, deposit a mineral cement that would connect them together and make sandstone. So I'm going to write for my rock origin, I'm going to write clastic, and sandstone is my rock name. Now, sandstone obviously is used in many things, from decorative stone, landscaping rock, countertops even, and very useful. Building stones. So sandstone is a very common rock out there. It is also a silicate rock, and silicate rocks make up over 90% of the rocks you find out there, and they're made primarily of silicon and oxygen. We looked at many silicate minerals last time. Those silicate minerals make up silicate rocks, and those are the most common. So the rocks we see here today are the ones you're going to mostly see out there in the real world. Sample number 4. Sample number 4 has clear, big grains. So we're going to call this coarse grained right off the bat. So I'm going to write in coarse for the grain size. And the grain arrangement then is cemented clearly. There are grains that are basically cemented together, I think these grains are fossils, actually. And they're cemented together with a lime cement. So I'm going to write cemented for the grain arrangement here, cemented. And then I'm going to write, the color is tan, and I'm going to write fossils in here for the composition. Now it's a sedimentary rock, so I'm going to go to my sedimentary rock table, and I'm going to note that coarse grains of broken shell fragments, that could be it, or fossils. Now broken shell fragments, it looks kind of like more of a modern rock, and fossils kind of a smoothed over rock. So I think we have fossils here, but they're both cemented, both have calcite shells and are similar in color. So calcite shells I'm going to also add for my composition. Now I will note that when you look at these in lab, if you are actually looking at these in the lab, the samples I have are not this good. This is one of my prime samples I plucked from the floor of a quarry back in the day. The samples that you have are more gray, but they do have shells like this in them. It is a clastic sedimentary rock, organic, because it's made from once living things. So it's an organic sedimentary rock. That's its origin. And I'm going to call this fossiliferous limestone. Coquina looks like really bright in color, broken up shells like you just plucked it off the beach. This one has a look of being preserved and kind of put together and fossilized. So this would be more of a fossiliferous limestone. So fossiliferous, that's the word of the day. That's a great word, fossiliferous. So there we go. So I'm going to write in organic for the origin and fossiliferous limestone for the rock name. And there it is. Okay. Moving on to the next one, number 5. Sample number 5 looks familiar, right? Most of you may have seen this before on your countertops. This one has a pink and white look with some black flecks in it. Those black flecks are probably biotite or pyroxene, I'm guessing. You can see there's pink minerals and white minerals. We saw plagioclase in lab last time. The pink ones are like plagioclase, they're orthoclase, and these are feldspars. When they actually weather down, they weather into clay minerals. And there's also some clear and gray looking things in here. That's the quartz. And you can see it's all kind of like, all the minerals are glassy, and they're reflecting the light like glass. So you can see the individual grains. This is definitely a coarse grained rock. So we're going to write coarse for the grain size. And we're going to write interlocking for the texture, because when you look at this rock closely, you're going to see that these grains are indeed put together really well. It doesn't feel like they've been like sugary grains like the sandstone, where they've been put together. These are clearly interlocked together and grew together, primarily when this rock cooled. Now, to get grains this big, the rock has to cool very, very slowly. When the rock cools slowly, you note that it will have time to have all the minerals in the magma stretch out. And this is an igneous rock, so the mineral grains will stretch out and form big crystals. All right. The composition and the color, I'm going to call the color white / pink / gray / black flecks. So it's an igneous rock. I'm going to go to the igneous rocks table, and let's get that to focus. Focus, please. All right. And this is our coarse grained rock. Okay, so it's going to be one of these 3 at the top. Coarse grained, either granite, diorite, or gabbro. Interlocking grains, it says here, grains chemically bond when cooled. It is light pink, some black flecks. So that would be the one, rhyolitic in composition. So I'm going to write rhyolitic in for my composition. That's actually the name that they refer to the magma, rhyolitic magma. And rhyolite is a fine-grained version of this rock, which is called granite. See that its origin is intrusive or slowly cooled. So for rock origin, I'm going to write intrusive. And for the rock name, granite. And there you go. All right, sample number 6 then. Sample number 6 is another very common rock. This rock is actually used in roads The little pebbles that asphalt has in them are these. The ocean floor is paved with this. You can see that the grains are fine compared to our coarse grain one from before. These are clearly fine grains in sample number 6. So I'm going to write fine. The grain arrangement is interlocking. It looks almost sugary like that sandstone, but you can definitely feel the difference. It's smoother and it feels like the grains, and it looks like the grains have been basically chemically bonded together. So I'm going to call this interlocking. There's no kind of banding. That banding or layering we call foliation. That would tell us it's a metamorphic rock. It's not present. And this is definitely black in color. So I'm going to go to my igneous rock chart, and I'm going to note the fine-grained rocks, and the fine-grained rocks are rhyolite, andesite, and basalt. Okay, and so interlocking, grains chemically bonded. I have basaltic, black or dark gray, rhyolitic, tan, white, light gray or pink, or intermediate gray with white and black flecks. Nope, it's basaltic, definitely. So its composition is basaltic. Again, that's what they refer to the magma as, basaltic. And its origin for basaltic is extrusive, which means quick cooled. Extrusive. The grains did not have time to form large in this one, and so our rock name is basalt. Now, you will see a rock today in the unknowns that is very smooth. And that smooth texture is where you have no grains. And so a rock can cool so quickly that it ends up having no grains. So very interesting. So I'm going to encourage you to go on to part 2 and answer the 3 questions there, comparing texture and composition of rocks. And then we're going to move on to part 3 and talk about the unknowns. All right, for the unknowns in part 3, I'm going to take the time to go through and kind of show you the rock closely, but you're going to be responsible for writing down the grain size, the grain arrangement, the color, and then going to your rock table and finding and writing in the composition and the rock origin, and finally the rock name. And I'm going to start with unknown number 1. Unknown number 1 is that glassy rock. The grains are so small that the thing is really smooth. When broken, has these curved edges to them, and this curved sort of arena-like breakage is called conchoidal fracturing, and that's indicative of this particular rock. But as you can see, no grains. It's glassy in its grain arrangement. This is a special type of grain arrangement called glassy. So you're going to write that in for the grain arrangement. The color is black, and you're going to go to the igneous rock chart to find the rest. The igneous rock chart will tell you the composition of this rock, its origin, and the rock name. Sample number 2, unknown sample number 2 is medium grained. I would call this actually probably medium-ish grained, right between fine and coarse. It is sugary, but it doesn't feel like the grains are cemented. They look more interlocked. So you're going to write interlocked for the grain arrangement. The color obviously is white, and you're going to go to the metamorphic rock table to find the composition of this rock, its origin, and its rock name. Unknown number 3 is a banded rock. Very clearly you can see this. It looks like granite, but it's the banded version of granite. And we haven't talked a lot about this, so I'm going to talk a little bit more detail about this one. The grain size is coarse. You can see the individual grains much bigger than the others that we've seen. The grain arrangement is foliated. This is a special type of foliation. It's really, really foliated. Lots of heat and pressure made this rock band out into layers. The typical origin of this rock would be granite, and granite, when it's pushed and cooked, looks like this. Obviously, the color is pinkish, whitish with black bands. And you're going to go to the metamorphic rock table to find the name of this rock, this heavily banded, highly foliated metamorphic rock. Isn't it nice? And unknown number 4. Unknown number 4 is very light. This almost feels like it could float in water. It was cooled with air bubbles in it. This is typical of what would happen in a volcanic eruption, where frothy magma and explosive water vapor gases fragment the magma and blow them out in all directions, leaving air bubbles in the rocks to freeze and form very light rocks, almost able to float in water. Now this is like its cousin pumice. This has air bubbles cooled in it, and this texture then would be referred to as frothy. So the grain size, if you look at the grains, there's not individual grains. They're more just all kind of like frozen up into small. So this grain size is fine, and the grain arrangement is frothy. Color is black, or maybe even a reddish black. And you're going to have to go to the igneous rock table then to find the composition, the rock origin, and the rock name for this. And unknown number 5. Unknown number 5 really feels like sandpaper. It's just like sample number 3. It's got that sugary grain. It's medium grained, but it's definitely cemented. Okay, and that cemented grain feel makes it feel like you can actually rub some of this stuff off. It's clearly not chemically interlocked. Of course, the color here is a light gray, a very light gray. And you're going to have to go in and look at the sedimentary rock table for this one to find its composition, its rock origin, and the rock name. All right. And so that is the 5 unknowns.
Party rock! Yeah.
I wanted to show you some rocks of special look, just while we're on the look of rocks here. I think it's kind of neat to show you some of the cooler rocks that I have as samples for. First of all, I wanted to show you this one. This one is granite's cousin, gabbro. Gabbro is the basaltic version of granite. It's got coarse grains. You can see them sparkling, and they're all black, dark gray, and green, and it's beautiful. When you polish this rock up, and you can use it for decorative building stones, countertops, and so forth. So gabbro is a really cool looking rock I wanted to show you. That's from slow cooling of igneous rock and basaltic magmas. The second one I wanted to show you is this one. This is called conglomerate. And I want to show you this one because it's got rounded pebbles that are cemented together. And this is formed in a river setting where you have a fast-moving river and you got lots of pebbles and coarse grains. They get cemented together to form this. They find this stuff on Mars. And this tells us that Mars perhaps had flowing water at one time. So it's pretty neat, pretty nifty. I just wanted to show you that because we hear about this rock conglomerate. When plants, particularly land plants, die and get buried, they become heated and under pressure as they get buried deeper in the earth, and they form coal. So this is a piece of coal. You can see that it's very shiny. It actually has even like a little bit rainbow hue to it. So it's very neat looking sedimentary rock formed again from sedimentary processes, but it's an organic sedimentary rock formed from once living things, plants, particularly land plants. And finally, I couldn't leave you out of this lab without showing you a piece of schist. Isn't this a beautiful piece of schist? This piece of schist is very pretty. It's silky looking. It's actually a mica schist, so it has muscovite in it, which is a very flat grain. It's the product of metamorphism, heat, and pressure. And it even, look at this piece of schist, even has some chunks of dark stuff in it. Those are actually garnet crystals. They're very beautiful purple crystals of garnet. And so you see these commonly when they form when rocks undergo a heavy metamorphism, lots of heat and pressure. So isn't this a beautiful piece of schist? I had to show you that. All right, so that's the bonus material there today. Please go on and complete part 4, which is using the information from the front page of the lab to answer some questions on classifying rocks. And then you'll be done with the lab. I hope you enjoyed it. Thanks for joining me for this.
We built this city. We built this city on rock.
Well, I hope you're able to learn a little bit about rocks today, how geologists tell them apart from one another, classify them, some of their uses, and really were wowed by some of the beauty of the rock. So thanks for joining me. Hope you had a good time, and we'll talk to you soon.